Number 58 on page 174 is a precipitation reaction. Every time that we do these problems, we're going to want to start with a balanced chemical reaction. So in this problem, we are going to be reacting barium chloride, get some of this stuff out of the way, so barium chloride, which is aqueous because it has a concentration of 0.1 molar in the problem. We're reacting with iron 3 sulfate. Remember that the Roman numeral means that the charge of the iron is a 3+, sulfate is SO4 2-, and so the iron, when you crisscross, is Fe2SO4 3. This is also aqueous because the concentration is given in the problem. This is a double displacement reaction or a precipitation reaction, so we will be getting barium sulfate and iron chloride as products. Now when we are looking at the products, we have to determine if they are aqueous products or if they are precipitates that are going to fall out of solution. You are supposed to memorize the NAG-SAG rules, and one of those rules has the S, sulfates, in it. Sulfates are soluble unless they are with PMS or Castrober. Castrober representing barium as one of those substances. So this will be our solid precipitate. This is going to be an aqueous solution. We are starting with 100 mils of 0.1 molar barium chloride, so I like to use the molarity equation. So I have 0.1 molar. How many moles of barium chloride in 100 mils, or 0.1 liters? When I calculate this, I will end up getting 0.01 moles of barium chloride to start. I will repeat that same process with my iron 3 sulfate. I have 0.1 molar. How many moles of this will I have in 100 mils, or 0.1 liters of the iron sulfate? Again, I will get 0.01 moles of the Fe2SO4 3. You may have noticed that I forgot a step, and that step was balance, balance, balance. It has to be a balanced chemical reaction. So I should have a 3 there and a 3 there with 2 iron chlorides being produced. If you are given the amount of each reactant, we need to figure out which one of these substances is going to be the limiting reactant. Some of these things, it might be easy to see that because this is a 3-to-1 relationship and I'm starting with the same amount of each, it is maybe obvious to you that the barium chloride is our limiting reactant. If it is not obvious to you, you're going to have to go through the calculations and say, okay, if I have 0.01 moles of barium chloride, how much product will I produce? And repeat that same thing with, if I have 0.01 moles of iron sulfate, how much of the same product will I produce? The reactant that produces the less product is your limiting reactant. So because this is my limiting reactant, I'm going to work with that substance, and I say I have 0.01 moles of BaCl2. How many grams of the product can I produce? So I first have to do a mole to mole ratio. There are 3 moles of BaCl2 to 3 moles of BaSO4. In my next factor, I need to have moles of BaSO4 on the bottom, and I'm going to get that to grams. In order to find the molar mass of BaSO4, I'm going to have to add the mass of 1 barium, 1 sulfur, 4 oxygens. When you do that, you would end up getting 233.4 grams of BaSO4. So now to calculate, it would be 0.01. You can multiply it by 3 if you want to, but if you look and see that the ratio is a 1-to-1, you can ignore that. 0.01 times 233.4, and I will end up getting 2.33 grams of BaSO4 are produced when these two substances react.